Hi guys, welcome to the session. I'm very glad to see you here. We came from IBM Big Data Group. My name is Jun Yang, and you can call me Terry as well. I'm the lead of the graph database development. And allow me to introduce my co-speaker, Jin, who is the architect of our team. So we are going to talk about enterprise graph analytics today. So we will show you how to do the enterprise large-scale analytics based on the graph technology. And this is the agenda. Firstly, I will show you the challenges in hybrid data analytics and then give you a case study for how to use property graph to resolve the problems. And finally, Jim will show you how to choose a graph database for enterprise and how to make it qualify for the enterprise requirements. In most of the company, thousands of systems throughout all the organization. The data come from the different applications. It can come from the logs application, sensor, document. Some of them is structured or unstructured. This data will load into different data systems and for analysis. This will help company to provide the decision making and do some strategy things. But the data may cross different data systems. It may go through the master data management and then go to data warehouse or Hadoop and end up in a report or some other system. So you need to notice this. Different data systems may process or define the information differently. So the question may ask it by different roles. The data warehouse architecture may ask, what's the source to target mapping of our data warehouse? And audit people will ask who access the sensitive data in no working time. And the data architecture will want to know how to ensure the data quality, and the business guys will ask what's the total sales or total quantity calculated. Can you show me the lineage? So in general, we will use data governance to handle these challenges. It includes the lifecycle management, data quality management, master data management. And data quality management has correctness, consistency, and metadata. So you can see each of them is a big topic. So we'll just focus on the metadata today to show you something about how to use the graph to handle these problems. Okay, what is the metadata? It's the data used to describe other data. Based on how complex of this metadata is, we have simple metadata and rich metadata. For example, in a file system, on Linux, the inode describe how this file or directory looks like and what's the relationship and the modification time, the permission. And the DB, the data warehouse, has schema to describe how the table or view or some other things looks like in database. So how to manage the metadata in a hybrid data analytics environment. So everything cross-platform and servers. So we will go to the next part. I will show you to use the property graph technology to do the metadata management in data quality. So the traditional solution of metadata management is usually limited in one server or use the relational use relational DB as the backend. So it's not that good to handle the relationship with high degrees. So it looks like a point with many limitations. And if we use the property graph-based solution, everything can be organized as a panel, on the panel. So you can integrate the metadata cross-platform, cross-servers in hybrid. And if the metadata in high volume, we can use large-scale graph database to handle the storage pressure. And the efficient query can make you easy to do the analysis. You can easy to find the lineage, and the metadata can be wide range managed. So what is the property graph? The property graph consists of vertices and edges. And the vertex represent an entity, like a person, host, or a location. It has a number of properties to describe how this vertex looks like. And it can be also tagged with a label to show what's the role of this vertex in your domain. And the age. The age represents the relationship between two vertices. So it has a direction, and it also can have numbers of properties to show how this edge looks like. What's the relationship between these two vertices? So the property graph is one for relationship and intuitive modeling, expressive querying, and latent for analysis. The graph query is a native way to analyze the relationship. You can do query against a graph with different conditions, and you can even do something like circle, do something count, but it's less complex than circle, and it can handle high degrees of relationship in a big graph, and that helps you to easy to find the relationship. The graph schema can make the data visualization more easy, and it's easy to explore the relationship in high degrees. So this is a case study. We want to use the metadata management for audit. For example, the data theft risk. With many data theft incidents, we found this. Most data stolen in non-working time and by internal person, and the over-granting of privileges may cause this happen. So what we should do, here is the detailed steps. So firstly, we will ingest the metadata into graph database, and then do feature selection by using the query native in the graph, and do some advanced feature selection based on the algorithm provided by graph, and then do modeling. We can associate the graph data and other data from other systems, and then we can have a business recommendation for the company. So I will show you the steps one by one. Okay, this is the data ingest. Before we doing this, we need to modeling the graph. So we need to identify what's the entity, what's the relationship, and what's the attribute for each of them. And in this case, we have a user, which represent an end user, and the program represent some process, jobs, ETL, some data processing, and the data represents the basic units of the data source, and etc. And the relationship, we have the user to run a program, and the program can read the data as its input. And we also need to define the attribute for each entities and the relationships. And then we will put this to a graph mode. So we have the vertex user, program, and data, and the user has relationship with program as run, and the program has a relationship with data as read, and each of them have different properties to describe how this vertex and how this edge looks like. So at this point, we can ingest the metadata into this data mode, and the metadata are integrated. So we can use graph-based traversal to doing our analytics. So the next step, we will do the feature selection. So based on that model, it's very easy. We can use the query natively in graph to doing this. It's easy query to find who read the sensitive data in non-working time. So we will initial graph and traversal the vertex. The department is equal to sales, and in age is read, and out vertex had label with program, and then in age is run, and has the time step hour is not between 9 and 17. That is not working time. So we will get a list of user, but the user list may be a large, but not everyone should be the factor to steal the sensitive data. So we need to do further advanced feature selection. We can involve some Spark computing here to do some algorithm, for example, the Pagerank to find the user who had access to the large amount of data, which means that the user has more privilege in this environment. They can do many things they want, so they have more suspecting in this case. So, and then we get the user list from the advanced feature selection, and we can associate this graph data with our ERP system. We can get the information of employee, the violation things, and some people is not a salesperson, has access to this data, and maybe some R&D person, they are doing developing things or testing things and access the data. And some people have some violation event recently should be the suspect. Based on this model and the data from different systems, we will do association analysis, and then we will provide auditor recommendation to the company to say who will be the most suspecting person in this event. So we can focus on these people. Okay. Okay. This is the case study. And next, I will invite Jin to speak this part about graph database in enterprise. Okay, thanks, Jin.
Thank you.
Welcome.
Jin gave a nice introduction to property graph and also described a use case for graph in the enterprise. And I will continue the discussion on providing a solution for the use case that Jun just described. And this is the overall system diagram. You can see is the graph in the enterprise IT system. On the left side, you have the data source. If you look at this diagram, it's very similar to a ETL system or in the traditional sense. On the left side, you have the data source, which is where your data are, and which includes also the metadata. The metadata, we call that graph metadata, because the metadata will be stored in a graph. In the middle is a system that stores the metadata and that you analyze the data from the data source. It's basically a big data version of the traditional ETL system for data quality analysis. Of course, on the right-hand side, you have your business application that you want to obtain derive results, quality results from the data on the left side of the data source through the middle tier, which is the enterprise data quality system. And we have the Titan at the bottom, which is the graph database that I'm going to describe in the next slide. Do remember that the metadata is stored and modeled as a graph and stored in the graph database, as Jun just described. And there's a lot of advantage of doing that. Jun has described that why it's good, it's nice to store the metadata in the graph database, because it's for the modeling of the relationships. So the next topic is how to choose the enterprise graph database. These are the criteria or standard that we came up with, that how you can choose a graph database for your enterprise use case. Data storing feature, operations and manipulation features, the graph data structure, query feature. So this is a long list. I'm not going to go through the details of each of these items here, but I can give you some examples. For example, the first one, data storage features. It is going to be stored. The graph going to be stored in file on HDFS, or it is going to be stored on a relational database, because the data has to eventually go somewhere. The graph data has to eventually go somewhere. Is it going to be stored in a partitional database, or is it going to be stored somewhere, or is it going to be stored in a NoSQL database, for example. So since we are talking about the big data area, and we want the data to be stored in a place that is suitable for big data usage, and that's one of the criteria. And we'll talk about Titan in the next slides, which happens to match all these criteria we described. And also, we want to look at the data structure, the graph data structure, the query features. For example, what queries that it supports, how do you transfers, how do you do computing on the graphs. I will talk about Titan later as well, because it supports the Gremlin transversal language. The graph data structure, how do you model the data, the vertex, edge, and can you have in and out among the vertices, or can you have different relationships? For example, can you have multiple properties on the edge of the vertices or the labels? So these are the criteria that you want to choose something that fits your enterprise graph needs. Okay, Titan is a distributed graph database. It has been around for a while. In fact, it's one of the first graph database for big data. It's open source. It's based on Tinkerpop. Tinkerpop, by the way, is an Apache project, Apache Tinkerpop, and it supports the Tinkerpop Gremlin transversal language. It's open source, and it has these nice features. It's totally distributed, and it's scalable. It supports transactions, and it supports different search. It's geo search, geospatial, and numerical range, and full text search. So basically, Titan is a graph database that is built for big data. It can support millions of vertices and billions of edges. The edges are relationship. Remember, the edges are the relationship between the vertices. And this is overall the architecture of Titan. You have the application on the top, and then you have the APIs to access your graph, which is red color over there. And then you have this query layer and the graph processing layer in between. And at the bottom is your storage layer. Storage layer is, we choose Hbase, which is a distributed NoSQL big table data store. I would assume everybody knows Hbase in the room here. So at the bottom is the data storage layer. We use Hbase, and also you can have a search backend that help you to speed up the query to the graph. We choose Solar. It's a search backend. It's also a well-known search backend. So all this putting together is Titan actually, including the APIs to access it, the Gremlin API, and the graph processing layer in between, the transaction layer in between, and the backend at the bottom. You have a nice graph database, graph processing, graph database. You can do OLTP, transactional processing. You can insert, retrieve, transverse the graph, and also you can do analytical work on the graph. On the left side, you can see that through the Gremlin graph computer, you can do computing on the graph. Basically, it's like a job, MapReduce job, a Spark job. You massively transverse your graph and trying to find insights, relationships. A very simple example is Pagerank. Everybody knows Pagerank, and that can be implemented as a Spark graph transversal program that you can run against the Titan database, and you get results. You get the Pagerank results. And this slide is a little more details about the backends, and I'm not going to go into the details here. We use Hbase. It's a nice distributed, very scalable NoSQL data store, and it's suitable perfectly for Titan, because remember Titan is a property graph. You can add properties. You can add edge relationships. For example, a friend. You can add friends to a person. You can add the books a person read. You can add the movie a person watches. Basically, you can add arbitrary relationship to your graph. And Hbase is a NoSQL database. It fits the data model very well, because if you know that Hbase is schemaless, you don't have to define a relational schema up front. You can basically add a column, insert a column, put a column randomly at any time. So it suits pretty well. NoSQL database is perfectly suited for a graph database in this case. And also Solar. Solar is a very fast, very usable full text search backend. It can do a lot of things, full text search, numerical, range, spatial, geospatial search. It can do a lot of things. And it provides the interface that we need. It has a REST API. It has a cloud mode that you go directly to the Solar backend. So this backend suits very well, and it's a full integrated part of the graph system. So we talked about the criteria that the standard we try to choose for a graph database. And on the top, the green colored check mark that we put there indicate that those two, Titan plus Hbase plus Solar, I mean actually Titan includes Hbase or Solar at the backend. So all this together, it satisfies, it complies pretty well to our requirement. data storing features, operations, graph data structures, and the query features, and the schema and the instance representation. Titan supports, you can define the types, the data types on the properties, on the edge labels, on the properties, on the vertex labels as well. You can define, for example, string or long number or numerical number, or you can even define geospatial types on the graph properties. So what I was trying to say is that, okay, this Titan plus this backend together fits pretty well as a good solution for enterprise graph solution. So we still have a few criteria that I have not talked about yet. For example, the easy and centralized management and these things, and this is what's going to come up next. And so we come up with, for our graph use case, we come up with a platform basically that lets you manage Titan easily. It's through the Ambari, the Apache Ambari. A lot of you probably know Ambari. It's a installation, cluster management, cluster installation framework that you can do a lot of things with. So it's very natural that we manage Titan through Ambari. You can use Ambari to do Titan deployment, deploy Titan, and Titan server operations. Titan has a standalone server, the Gremlin server. You can start the server, stop the server, and do service track through the Ambari. So it's all part of a comprehensive platform or solution that you can build your enterprise data analytics use case on graph. Through the Ambari interface, do the Titan deployment, operations, Titan configuration. The Ambari is going to manage your Hbase cluster, your Solar cluster as well. It's all part of the solution. Titan configuration can configure Hbase backend, Solar backend, and I can, of course, if you have if you want to use the Spark computer feature within Titan, the Gremlin Spark computer, you need a Spark installation as well, a Spark cluster. So it's all going to be done by this Ambari interface, Hbase, Solar, Spark, Titan server, and last not the least is the security. I have not talked about security yet. Security is an important part that you want to take care of in the enterprise world. It's very critical. And so we have some security support that is enabled for Titan, for the database, graph database, SSL, SASL, which takes care of the authentication, and you can integrate with LDAP for your user group management, and it supports Kerberos and Knox. Knox is a Apache project, Apache Knox, that lets you authenticate and manage the access to your cluster or to your server. So it's all integrated together. And also, last but not the least, is the Hbase access control. The data is stored in Hbase, and the search is on Solar. So it's all integrated together that you have the nice security feature to guard access to the graph. Okay, so we put additional check marks over here. So the easy and the centralized management is taken care of by Ambari, and that is the check mark that we put over here. And this is a interesting diagram as well. You can expose to Titan as a service instead of let you manage the cluster, the Hbase cluster, the Titan cluster, the Spark cluster. So we expose Titan as a service, and through a REST interface, you can see on the top, it's a remote user. You can access the Titan service all these graph service as a service. It's through the Gremlin server. It supports the RESTful API and also the WebSocket API. So this diagram is just trying to show that, okay, we expose the graph as a service. Everything else at the bottom of the diagram is the same as what I've shown previously. Okay, so we have additional check mark, and we're able to put it as a service, which is nice to have. Expose service. And next is the security. We talked about security, and this diagram just to give you a little more details and the security enhancement. And the next slide is actually going to be more, yes. And you can see the remote user, when it access the server or access through the service, you have SSL, which is taking care of the encryption. And then you have Knox, which takes care of the authentication and access control. Then you have the SASL, which is another protocol for authentication and access control. And on the left side, you have the Hbase access control. Basically, you grant or revoke access to your Hbase tables. That can be managed as well. So this is a more detailed diagram on the security that we put into the Titan graph database. It also supports kernels. You can do a kinit. You can do a key tab using key tabs that grant the users, authorize the users to access the graph database on the right side. You can see LDAP, kernelized Titan users, or OS LDAP Titan user. And the cluster can be kernelized as well. It works well with a kernelized Spark, kernelized Hbase, and also kernelized Solder. So it all works well together. Okay, so we check out the security features. And then the last thing I want to talk about is the Spark graph computer with TitanDB. And you can see this small diagram that we had previously. We have the Spark over there. And now I'm going to expand that a Spark illustration here. So remember we talked about a Tinkerpop Gremlin. Gremlin has a Spark or OLAP interface that you can basically run a job to process your graph data, either through a MapReduce Hadoop instance or through Spark. So Gremlin graph computer is an abstraction layer. You can plug in MapReduce. You can plug in Draft, which is another Apache project, and also you can plug in this Spark graph computer. And then the graph processing job. So we are talking about OLAP analytical work instead of the transactional that you insert, you query, you transverse the graph. If you want to do, I was giving an example, the Pagerank, for example, all can be run as the Spark job against the Titan database and get your results. Okay, so we put a last check mark over there, which is the computing part. Okay, and this is the last thing I'm trying to talk about is Genus Graph. I know there's already a section in this Hadoop Summit that is all talking about Genus Graph. So what I want to again mention, emphasize here that Titan, the last release of Titan was September of last year. And that project has been dormant for a while. And IBM, Google, Holdenwork as well, pick up what has been left from Titan. And GenusGraph is a new project. It's basically a fork of Titan. But, and a lot of, it's become a very active community now on GenusGraph. A lot of contributors and contributions and active communities. We're trying to carry what Titan has left over, and we will continue to work on this nice graph database. It's a new Linux Foundation project formed to continue the development of the graph database. That's all. Thank you.
Thank you. You're welcome. Thank you.
Questions, if any? Yes.
So would you be able to apply security at the vertex attribute level?
That's a very good question.
Could you repeat the question?
Yes, I think the question is, can you apply security on the graph vertex and edge or property level? That's a very good question. Titan or even GenusGraph currently does not support that. But I think it's a nice feature that can be added. And of course, we welcome contributions in the open source community for Titan or for GenusGraph. I think that it's not supported at the moment. There are ways to work around it that you define your graph, how you can allow access certain people to certain part of the graph. You can partition the graph. There are different ways to work around that, this lack of this particular feature. But again, yes, to confirm, it's not really supported.
So for the computation, do you also consider the GraphX or GraphRim?
Yes, that's a good question as well. I think the question is how the Gremlin graph computer or the Gremlin Spark graph computer relates to GraphX.
Yes.
It's an interesting question. I think the relationship is like you can go from Spark. For example, you have a Scala program. You can go from Spark, and then you use the GraphX to go against your graph. But remember, the interface is different. Here, the interface is from the Gremlin interface, from the Apache Tinkerpop Gremlin graph computer interface. So it's a different route. I can give you an analogy. It's more like, okay, let's give you an analogy. You heard about the Python Spark or Spark SQL. So Spark SQL is built-in from Spark that you access through a SQL interface to your data. But a Hive is a Hive interface, but it runs on Spark cluster. It runs on the Spark workers, executors to access your data. So the analogy is similar. You have the Gremlin interface, which defines a set of interfaces that how you can run your graph job. But that job can be dispatched to MapReduce, or it can be dispatched to Spark. But GraphX is totally designed from the beginning to run from Spark, to run from Scala, to go run against, to run on a Spark cluster against the graph. But there are limitations on GraphX. I'm not sure if it supports the Titan DB yet, because you do need a connector. It's like you go from a Spark to Hbase, you go from Spark to a Packet file, you need a connector. So I'm not sure if the GraphX supports the Titan DB, there's a connector for that or yet. But I think you understand the relationship now. So it's the two different interfaces. But I have to say that Apache Tinkerpop Gremlin transversal interface is becoming pretty popular. You can go to the Apache Tinkerpop Gremlin interface. It's they become pretty much a standard to access graph database and graph transversal. So hopefully that can continue. And on the other hand, I cannot say for sure how these graph X they can merge or they can work together.